Sheree Stokes, and I'm the Executive Director for Tech MGM. And I'd like to welcome you to our Leveraging Data for Economic Development webinar series. Today's week 5 of our series and is presented by Clarity Innovations. Over the last 4 weeks, we've had an opportunity to hear from tool providers, government entities, research organizations, and also community hackers to discuss how we use data to impact and leverage our economy. This week, I'm really excited to introduce one of our community's finest technical and IT professionals, Zach Lewis with Clarity Innovations. I've actually had the opportunity and pleasure of knowing and working with Zach for quite some time. He's not only a brilliant software developer, but he has a wealth of knowledge in programming, information assurance, and emerging technologies. Today, he'll discuss with us machine learning, artificial intelligence, and how these items can be used with data that we find right here in our very own community in Montgomery. Please welcome Zach Lewis.
Good afternoon. I'm so glad that you came out today. And like it says, this is sort of a machine learning 101 for business, teaching computers to figure something out all on its own. We're not going to go too deep or too complex, but we want to give you a good understanding so that you can start, if you haven't already started, to incorporate this in your business processes and to work with the many vendors that provide solutions that don't require you to have really any major tech skills. So when I talk about there are tons of, to go more deeper or to get it better or more comprehensive, tons of YouTube videos. Most of the vendors, Google, Amazon, and others provide excellent tutorials on their platforms and how companies are using those. So we encourage you to, in the future, to take advantage of some of those resources after you see some of the benefits. So my starting point, so in the 1980s, I always call myself the old computer guy, or coming up during the age of baby boomer. At my age, we didn't have any home computers or before personal computers, before cell phones, back in the good old days of dial-up phones, dial phones, and one phone that sat on the wall. But we all had visions of the future. So if we think of the movie, I have here the HAL and the old Terminator. These are all before a lot of the technologies we see today of self-driving cars. And even the robot vacuum, we now can buy Roombas. And then of course, chatbots, which hopefully you're already starting to take advantage of through the many resources that are out there. But the holy grail, as you see, is that one right above chatbots. Computers haven't been able to program, and that's been one of the futures, or been able to do things that require some creativity. So just to give a little bit more on the background, when we think of machine learning, really one of the categories, I'm going to try to stay in this lane of business intelligence or decision support systems. And all of those were the foundations for a lot of the tools that are in place and for AI and machine learning. You do need your data organized and understood. Multi-dimensional databases of connecting various different events or states so that you have an understanding, at this particular time, this event happened and this affected my revenue. We see today with COVID and some others, if you were predicting, you couldn't predict that everything would be shut down. But had you had a machine learning algorithm and had built systems where what would happen if we couldn't come into the office, and you had already done those type of analytics around understanding your dependencies on physical presence and not preparing for the remote world that we live in today, you realize the challenges that we see so many happening, so many people are suffering with. Knowledge management, when we think of the process of managing knowledge, at that time, back in the 80s, I was the knowledge management executive consultant for the team at Nationwide at that time. And we had a number of initiatives. So if you think in the late 80s, early 90s, just way before the internet. So we should add that, before a lot of home computers for regular users. We were building systems to be able to understand contracts. I worked with the legal department, and we put together systems that was able to read documents and read the information from the LexisNexis and other sources, and be able to quickly help the attorneys to see what's the business risk, what do we need to respond to. So managing your knowledge as we're in this new knowledge economy. One of the other systems we built was a initial knowledge management system. So at this time, there were no web servers that you could purchase. There wasn't the internet as you know it today. No cell phones. The advanced pieces were Audix. For some of you out there, you only had phone systems where you could do a limited set of automation. But one of the business challenges we faced was in the customer experience area. So within that, it took 6 months to train a customer service rep for all of the different financial products, insurance products, and all of the services that the insurance and investment side of the company provided for the many customers at Nationwide Insurance. So we set about re-engineering the whole organization. You know, as you can see from my diagram, we actually built the process where from the mail room, when mail came in, this is back before email, customers didn't have internet at home, mail would come into the mail room, we would scan it, we would then automate it into the systems. We had enhanced phone systems where we at least had caller ID to know which customer had called in. And right away, we could answer questions. So if a customer said, I put it in the mail, you should have gotten it today, we had zero turnaround as far as understanding what came in the mailroom and what the customer service rep had access to. Also, we connected into the mainframes and all the back-end systems to be able to provide them answers. And at the top level of our little circle, we took the experts, those that had all of the knowledge and knew how to answer every question, and capture that and put it into a knowledge management system. And then we've set up a website. Back then you had to download the open source, well, it wasn't open source, the freeware from NCSA. So we actually compiled and built systems, but we shrunk that time. We're now, you know, within a month, training them and connecting them, they could answer every question a customer had about their accounts and do it faster and increase that customer service and that customer experience. But all of this was about managing data, managing information, managing data flows. And if you think now, we would add machine learning to this. We could automate some of this. If they called in and they were asking about something, the system could automatically take in all the information related to their account and give them context-ready information, and then allow them to connect up, which you see today when you call. And immediately you get the answer versus it taking 20 minutes or escalation. The first person you call could get that answer and be able to provide it. And there's where utilizing systems that are able to understand problems and answer is so critical. But this is way back then. This is before where we are today, and why when I talk about decision intelligence and what you can do today with all of the resources of machine learning. Because for a business owner, you're really thinking about, I have to make decisions every day, and those decisions affect my revenue stream. And you're looking at all the potential decisions and your potential actions. And what will they cause? Will it cause a good effect, or may it cause, or will it not? Good or bad effect. So you have that set of potential decisions. If you had a system where you could put those potential system decisions and actions into it, and it could give you back a potential result, which is what a machine learning will give you an answer to, then you can actually make a decision and you'll get a result. And then by over time, hopefully your potential results are closer to the actual results. And you're doing all of that with the data and machine learning algorithms, and you're able to be more effective and be ready for most of the changes that occur within your business environment. I'm going to show you this one video from the author of that book, and we're going to see how this is going to work out.
Over the internet. So I've been curating some news articles about unintended consequences. Unintended consequences are the things that happen when we don't have a good blueprint for decisions, when an action we take leads to something that we don't want it to result in. And I did a search the other day for the occurrence of the phrase unintended consequences in books. Look at them taking off over the last few decades. At the same time, I did another search for the phrase decision making. For a while, we tried to conquer all these unintended consequences by writing about decision making. But look at this trough of disillusionment. What's going on there? People are giving up. Unintended consequences are so overwhelming, and the complexity of a global world and data and information and people mean that we're all just checking out. Good news is we don't have to check out. Bad news is 14% of organizations, even those making decisions that affect human lives and billions or trillions of dollars, only 14% of organizations actually have a rigorous approach to making complex decisions. If you didn't have a rigorous approach to building a 747, I certainly wouldn't fly in it. But yet that's exactly what we're doing with the most difficult decisions of our lives right now.
Oops. So you see, we understand that the complexity, managing complexity, and really every day, like I have here in this chart from the Harvest, at our desk in meeting rooms, every day of their working lives, knowledge workers hammer away in decision factories. Their raw materials are data, either from their own information systems or from outside providers. They produce lots of memos and presentations full of analysis. And really, it's all about making the right decisions. And now with AI and AI factories, we can treat decision-making as a science. We can convert data and make better predictions and insights into our choices, which turn and guide us and automate operational flows. So let's think about it. Can computers think? First, let's sort of bring it back a little. They really can't. You know, just a couple of days ago, you realize IBM made a decision to get out of the facial recognition software business. And this is because when we talk about machine learning and all of these technologies around AI, they're still guessing. They really don't know. And based upon the person who actually creates that algorithm, it can be biased because they didn't use enough data or they used the wrong type of data. And then, of course, there are privacy concerns. In fact, last year, since locally I'm the leader of the Facebook Developer Circle. And at the Facebook conference last year, of course, Facebook has lots of privacy issues and other issues. But this was a major theme of the conference as Facebook is trying to become more privacy aware and react. But they had a section on facial recognition and the bias. And they had an excellent speaker as they talked about how they're trying to train it so to be better at recognizing people, especially those of darker complexion, because the current facial recognition software doesn't do a very good job. And those are the challenges. And that's one of the reasons IBM and some of the others realize that if you're going to be a company of trust and transparency, you need to at least be clear about how these technologies that are being used aren't, they can't think. They're making guesses, and for certain areas, their guesses are biased and not what you would want in a world where you're seeking to be just and fair. So let's walk through, how do we make decisions? You know, we have data, we take that information, we apply and put some context on it. Then we apply meaning to it, and then some insight. Over time, hopefully we're developing from past experience and others. And then we make decisions. When we think of how machines do it, you've got data, you've got to clean that data. There are math models, there's real world data that you're pulling, and you're going to classify it. You're going to look at, are there patterns? You know, how is the clustering? And then you need to train it, and then you've got to, you know, make sure it's matching with your training. And we'll talk some more about that later on in the presentation. And then you actually make a decision. And all of that is math and data and statistics. A lot of the things we've been doing over the years, bringing those all together, you can make the decisions that help your company to move forward in a way that you couldn't in the past. So when you think of the areas, data sciences, without data, there's no AI, you know, and that's why as you know, someone who's been around from the beginning, and if you think 40 years ago to see how we got to this point, the reality, we knew it was data. Could we collect enough data? If I had enough data, it's why the grocery store wants you to sign up or get a card, and why Amazon is worth more than all these other companies that actually make stuff, because they actually have more data. They know what books you read. They know what you buy. They know where you live. They know your income because the credit card you're using, they have access to those credit reports and that information. And now with Alexa and some other devices, they have your voice. And all of these things are about collecting data. Now that you have the data, you can now start applying it, classifying it, and adding some tasks. And then the holy grail is machine learning. Can I get machines to do what we do? We collect the data, we figure out, and we make decisions. And because we have certain algorithms. So when we think of machine learning describes machines that are taught to learn and make decisions by examining large amounts of input data. It makes calculated suggestions or predictions based on analyzing this information, and performs tasks that are considered to require human intelligence. This includes the activities like speech recognition, translation, visual perception, and more. A while ago here's AI in 10 minutes. The slide has a lot on it, but if you think of what we humans do, we see, we hear, we interpret, then we understand and we take action, walk or move or do something. When we apply that to technology and computers, we're looking at symbolic learning, where we're looking at images and robotics and computer vision. There's some object recognition like we talked about. And those all are predictions. This is most likely that, or this is that. And then we add in statistical learning and speech recognition, natural language, and neural networks and recurrent neural networks. And all of these terms apply. But you realize that it's all about, I have data, I'm going to put a number to that data, and then I'm going to make a decision. So let's look at it from this standpoint. So if we think of the categories, there's patterns of classification, predictions, and financial analysis. Way back, I guess, before Y2K, so in the late 90s, first part, year 2000, I was working on Wall Street, building a lot of automated trading systems. And there's the reality. You can look at events and then build systems that react to those events. And for stocks, it's simple. Should I buy? Should I hold? Should I sell? You know, those were simple models for building out systems. Now, what data affects whether I should buy? Was it the weather? Now we could say it's Corona is now added to the models. A potential virus, you know, is the certain other companies buying other companies. collecting all that data, you can now build systems that buy and sell so that you're always making more. But we know they use it with credit card fraud and forecasting the weather and speech recognition, predicting heart attacks, real estate prices, manufacturing, and figuring out what are the routes and what are the things that I need to do in that perspective. So when we think about it, just understanding it, I have data variables that I apply. That's why machine learning is simple in concept, and the reality of the tools today make it easy for you to take advantage of them. You got data, historical pricing, and proximity to schools if you were predicting housing prices or whether you should buy a certain set of real estate. Crime rates, historical job and square feet, local government, taxes, current trends of each of those above. And you build out these graphs, and at the end, the machine learning algorithm spits out a number that says this is the decisions you should make. But multidimensional graphs, interconnection of everything, that's really how it handles all of this, how machine learning works. And one of the good things of being in Montgomery as a leader, we have an open data portal. And the local government has put a lot of data out there that you can start to build systems around this data to help you make better decisions. So there's data around, people calling in with just general questions, or paving, or infrastructure, sanitation, building permits, construction, ditches. There's also data on where the government's spending money. So if you're contracting with the government or plan on doing something, you can understand. Plus, along with business licenses, understanding what is the competition, what's missing, where are there some gaps, and taking that, and actually you can build automated systems around capturing this data and being able to plan and forecast and look at patterns in the past. Back then, when the budget was this and this event happened, how did they respond? What are they more likely to do? And there's details all the way down in historical data that you would use and you can use. There's even details on those meters. So if you think of parking downtown, you can see how the numbers went down once COVID. Yeah, there wasn't a lot of people. If you had an automated system looking at this data, you could see how quickly you would have went. Maybe we need, I don't need this. If you had a connection with, well, if we had so many people parked, then that affects what they buy and which stores they go in. And there are a number of ways that you can take this data, and it's all out there free and easy so that you can start building your requirements and even start doing a manual process before you start to develop systems that automate the decision making. Public safety, if you think of, you've got data on the crime and what's going on, how many fires and the incidents. So you can be aware if you're in a provider for things that support public safety, you might want to look at this data to understand trends and areas to make proposals on ways to enhance the public safety of the city. Detailed maps, and they even give you graphics to know what type of crimes and where. All of that's available now on the city's open data portal. Food access. This is where, now that we have websites and systems, they put up information to let people know, when the schools close and others, where they could get access to food, places that are providing that food. So if you come in contact with people that are looking, you see how information, you could have this data and automate it in systems, provide a phone app where people who are hungry, or maybe you see somebody they're like, I need this, you can immediately provide them access and information. Information allows. And there's training on how to use it that's free. All of this is part of the website. You can go out and look at, take classes that are free and learn how to use this data that the city is providing. You can learn how it's used in other cities. They give you examples on how preparedness and the response to COVID and others. You can search, because data is the foundation for machine learning. And you understanding and building algorithms that know how to produce the numbers that associate with whatever your business need or your particular area of interest. So if you think policy mapping, helping the government solve some of these issues, which all affect business, where you can plan. And that's why data is so critical. And you get all that information online for free. And this helps you to make fact-based predictions. So when we talk about this, we're really talking about the science of managing location intelligence. And let's see if we can watch this video.
What is location intelligence, and how is it changing the way we solve the problems of the future? Location intelligence uses spatial information to empower understanding, insight, decision-making, and prediction. It has applications everywhere, from retail site selection and solving traffic bottlenecks to maintaining and repairing vital infrastructure. Location-based insights are used in many ways. They can create safer, more efficient supply chains. Growers can trace spoiled crops back to the field from which they were picked. Better understanding the trajectory of hurricanes, tornadoes, and floods can help evacuate residents, reduce damage, and save lives, making cities and citizens more resilient to the increasing severity of storms. Modeling wildfire risks empowers local authorities to clear vegetation and coordinate their response to fires. In farming, precision agriculture measures soil moisture and crop health to deliver water and fertilizer only where needed. Optimizing production costs and maximizing crop yields is necessary to feed another 2 billion people by 2050. Location-intelligent organizations allow all participants to create, manage, and share information, making them smarter, more productive, and more efficient. 2/3 of business executives already use location intelligence to gain a competitive edge. More than half use it to create new market opportunities. For this reason, 97% of companies believe location intelligence is crucial to their success. Most say they plan to invest in location intelligence technologies. We've only just begun to explore the potential of combining spatial information with prediction. Just as we would have once been hard-pressed to imagine all the uses for smartphones, we're still discovering how location intelligence, combined with emerging technologies like artificial intelligence, will uncover new insights and provide a map of the future. Esri, the science of where.
So that's it. When we think about it, the science of where, unlocking data's full potential. And the city of Montgomery provides a lot of that data out there for you to use, and you can add your data to it. And then there are a number of vendors, like I spoke about before, that will help you to actually take that data and build systems for your particular business or area of interest. In these last few slides, I will walk through some of the details of machine learning. So if we think about, we've been talking about it, speech, translation, visual, input data, feed the learner. Machine learning system takes all that data and then it presents output, presents rules. So there are a number of categories. So if we think of it, machine learning, there's supervised. This is where you have your data. There's unsupervised, where you start look for patterns and clusters, and you let the machine go out and tell you, I think there's a connection between X, Y, and Z. And then there's reinforcement, where you set up sort of like a reward system, where you have goals, where you can say, the closer, if I do this, did I get this result? And you try options, and the numbers either move you closer to a particular goal, or it moves you further away, and the machine learning algorithm changes its action to make sure that it always is increasing the number to get to whatever your particular goal is. So when we think about it, supervised learning, there's an algorithm consists of a target or outcome variable or dependent variable, and you're predicting from a given set. Unsupervised, we don't have a target, we're just trying to cluster, and we see how many things are related. And if they're related, then they must be similar, and then have it make decisions about it. And then reinforcement, where we're training it to make decisions, and then based on the past decisions, what was it? Did it get better or worse? And are we moving towards our goal of improving whatever the algorithm was designed for? So then you can look at it, you can say, did I get the prediction right? You can have the algorithm based out of 100, how many did I get right and wrong? And over time, making sure your accuracy increases. Is there a popular metric, average of the square of predicted and actual values? Or the mean absolute? Is there another metric to find the average absolute distance, the distance between the predicted value and your target value? And then the algorithm keeps trying to figure out how to reduce that distance. So can computers really learn? Computers can only be tasked with making inductive predictions based on past experience. The future they predict will always be a continuation of past behavior of actors. And so therefore, and the correlation doesn't equal causation. So that's why IBM, when they made their decision, they were like, the risk to us of ending up like Facebook, of not being a reputable company and people looking at us with suspicion. We're going to get out of that business. So the people are like, hey. So, they can't judge whether something is real or ridiculous. It's just taking numbers. So if you're looking at what you're planning to do, make sure you have a clear use case. Start with the problem, not the solution or what you think it is. Start with the problem. What am I trying to solve? In simple stock market analogy, I want to be able to optimize my return on the purchase of stock. So there's a certain percentage I want to guarantee I hit every month. How can I make sure my algorithm matches that? And then know your problem before focusing on the data. What data do I need? What affects the prices? You might even want to limit that set. What affects the prices on these certain stocks? What events have happened and the stocks went up and down based on historical data? And then lean on, you should have some expertise with a team and what's been done in the past and data from a lot of those vendors, Amazon and Facebook and Google and a variety of other sources. They're collecting data and they sell that data. That's what they're in. Even Amazon's selling data. So what's the reality of what's going on? And then what features are contained for the prediction? What do I have that I can actually make a prediction versus a decision? So if you think your main step, problem definition, when we break it out into 7 steps, evaluation of the problem, data collection, data analysis, cleaning, pre-processing, training that data, testing and predictions, and deployment. But the most critical step is data collection. You got to ensure you don't have gaps. That's why with the facial recognition, they really don't have enough data so that they can actually create algorithms that are more accurate in certain data, certain groupings or certain areas. You need to keep it raw, look for opportunities where there's bias or you have missing values, change your structures, make sure you're not losing any data points. And you really need a data or knowledge manager. That's what we called it back in our day. You need to really understand. So that's why the main tasks are really around cleaning your data, gathering, cleaning, visualizing. Montgomery provides a lot of that, visualizing of data. You will have to do the cleaning and gathering. And then now you can apply models on it, and the rest of those make it real easy for you to build solutions. Other concerns and fears, they were thinking data is the new oil. Pessimist says everything's terrible, it can't get any worse. The optimist knows that it can get worse. And some of what we're seeing today, this is where machine learning, there needs to be some thoughts on how it's implemented, because there can be real problems with some of the major companies like Facebook, Amazon, Netflix, and Google. But that's why you really need to understand, because you are providing them with data, whether you know it or not, and they're using that data in ways you might want to make sure that you control. So Microsoft took a model of responsible machine learning. understanding and control and protect, driven by principle that put the people first and give tools. Make sure as you think about your solutions that you understand the risk of not taking a responsible approach to it. And we can't reiterate it enough. If your data is not clean, your model's not going to work. You really need good data. You need to collect as much as possible. You need to make sure you're getting the right type of data, diverse data, and make sure it relates to your particular problem set. Validation data. This is the other part. You need data that can help you validate the data that you already have, and test data. So data is not just on one side, it's on the validation and test side also. Please note that machine learning algorithms doesn't generate a concrete output. It's a probability of outcome. What is the potential result? And therefore, you can make decisions if that matches to what your real requirements are. And we'll close here. There are a lot of other resources that you can get out to, look at, and start playing with. There are free tools out there that you can download and start. And they have tutorials. They even have examples that might relate to your business. And if you have any questions, you can put them in the chat window. I don't know if we wanted to open up so they can speak, but.
I actually have a few questions, Zach.
Right.
You gave some tools and some resources that people can use. Would you say that, and if there's a good starting point for someone that's just getting into really doing machine learning and how they're using data, would you recommend anything in particular as a given data set to start with, or a tool in particular?
Well, I wouldn't recommend a data set. I guess the book that I referenced earlier, I would say, there are a number of them to help you understand how to organize your thinking and your data. Because, right, the algorithms, a lot of companies, once you understand what your goal is and your problem set, you can get the data from a variety of sources. And then they're like with here in Montgomery, we've got all that data out there for the city, and a lot of it can be used along with data you already have from your customers and your neighborhood, and plus other sources from Google or Amazon or others. So really understanding what your goals are, and really understanding it's not any different than the way you make decisions. And that's really helping people understand. So think about right out, what data did I need to make a decision? Can I automate it? And where would I collect that data and then build the systems around it? So, right, it is mapping to the way you do it naturally, and then building it with these new platforms. And they have tons of platforms where, right, in 10 minutes, you can go from, here's how I do it, now I can automate it and use this machine learning algorithm. So.
Okay, another question. Have you personally built any applications or used any local data sets that the end result and the information that you found was completely different from what you expected by using machine learning?
Yeah, and I should say with some of the data that I pulled from the city, and when we think of since that crime data is out there, it's really interesting to see there isn't a real pattern. In Montgomery, they say there are patterns, but when you look at it visually, you sort of get it that it's more complex than a lot of people view it.
Okay, and then my last question, and you spoke a little bit about this, but just a follow on about the integrity of data. Are there methods and or tools that can be used to maintain it and or increase the integrity of the data that you're collecting?
Yeah, yes, there are a lot of collection tools, I guess, for my early side, knowledge management tools. That's where really organizing your data, and you really need to start, companies should consider engaging with some data scientists and at AUM I know they have a number of courses. I was working with some students there that, you know, to engage those students in projects, partnering with them and getting them involved. And they can help them to understand how to classify it and organize it. Because, right, the same systems you have today can be utilized. And then once you've organized it, you can then apply it to some of the systems, Google or Amazon or some of the specialized companies. They're going to just take it either in your Excel format or in a comma separated list. But you have to understand your data and what you actually already have access to. And having a professional or even a student from AUM in one of the data science classes, since they have projects, have them sit down with you if you're not, or, you know, like we said, there are tons of complete videos on YouTube, and even the vendors. If you go to Amazon or Google, they walk you through the process. Here's how to get your data, use our cloud so you can take advantage of their services for, yeah, initially for free, but then later you pay them.
All right, those are the questions that I had. And I don't see any additional ones in the Q&A window. So I think we'll go ahead and close things up. Zach, thank you for presenting today. The session that you actually gave on machine learning was really good, as well as giving us an understanding for artificial intelligence, but really understanding how much we can do at our fingertips right now with the data that's currently available to us in Montgomery, and how we can go out and search additional data. I hope those of you that joined today will join us for our final webinar, which is going to be next Wednesday, June 17th at 12 o'clock p.m. It will be the relaunch of HackMGM. So one of the things that we'll do is really cover everything that we've talked about throughout the webinar series, and look at how we can start to make an impact here in Montgomery. Registration is available via the montgomerychamber.com/events website. And those of you have a wonderful afternoon, have a great week, and please stay safe. Look forward to seeing you next week.